So now let's talk about Amazon. Athena. So Athena is a serverless query service to help you analyze the data stored in Amazon S3 buckets. And to analyze this data, you're going to use the standard SQL language to query the files. Behind the scenes, Athena is built on the Presto engine, which uses the SQL language. So the idea is that users are going to load data into your S3 bucket, or you are going to load data into your S3 bucket, and then you would use the Athena service to query and analyze this data in Amazon S3 without moving it. So Athena is serverless and it analyzes directly your data living in your S3 bucket. So it supports different formats such as CSV, JSON, ORC, Avro, and Parquet, and possibly others. And the pricing is very simple. You're just going to pay a fixed amount per terabyte of data scanned. You don't need to provision any database again because the whole service is serverless. So Athena is commonly used with another tool called Amazon QuickSight to create reports and dashboards. So we'll see QuickSight later in depth, but Amazon QuickSight connects to Athena, which connects to your S3 buckets. Now the use cases for Amazon Athena are to do ad hoc queries, business intelligence, analytics, reporting, and to analyze and query any kind of logs that originates from your AWS services. So it could be your VPC flow logs, your load balancer logs, your CloudTrail trails, and so on. So as an exam tip, anytime you need to analyze data in Amazon S3 using a serverless SQL engine, you can think about Athena. Now, I've talked about performance improvements, and you can actually improve Athena performance, and this is the exam will test you on this as well. So first of all, because you pay for the amount of data scanned per terabyte, you need to use a type of data where you're going to scan less data. And for this, you can use a columnar data type for cost savings because you only scan the columns you need. So therefore, the recommended formats for Amazon Athena are going to be Apache Parquet and ORC. And it's going to give you a huge performance improvement. And to get your files into the Apache Parquet or ORC format, you must use a service that we'll see as well in this section. For example, Glue. Glue can be very helpful to convert your data as an ETL job between, for example, CSV and Parquet. Now, also because we want to scan less data, we need to compress data for smaller retrieval. So there are different compression mechanisms you can use that I've listed it right here. Next, if you know you're going to query all the time on some specific columns, you can partition your data sets. And partitioning data sets means that in your S3 bucket, you're going to have the full path with slashes, and each slash will be a different column name with a specific value. And so you're partitioning your data in Amazon S3 so that when you query it, you know exactly in which folder, at which path in Amazon S3 you need to scan for data. So here's an example of data partitions. So we have flight data in Parquet format, and then we do slash year equals 1991. So we partition by year, and we'll have one folder for each year. Then within each year, we'll have month. So month equals 1, and within each month, we'll have days. Days equals 1. And so when I do a query on Athena, and I filter for a specific year, a specific month, and a specific day, then we'll know exactly to which folder in Amazon S3 to get the data from, and therefore we'll only recover a subset of the data. Therefore, we'll have really, really good partitioning. Finally, the last performance improvement you need to do is to use bigger files to minimize the overhead. So if you have many small files in Amazon S3, Athena is not going to be as performant as if you had larger files, for example, 128 megabytes and over, because larger files are easier to scan and easier to retrieve. Another feature of Amazon Athena is the federated query. So you know that Athena can query data in S3, but actually you can query data anywhere. For example, in relational or non-relational databases, you can query objects and custom data sources. Would it be on AWS or on premises? How? Well, you use what's called a data source connector. It's a Lambda function, and that Lambda function is going to run the federated queries in other services. So that could be, for example, CloudWatch Logs, DynamoDB, RDS, and so on. So it's very powerful. For example, we have Athena here, and we have a Lambda function, and you have one Lambda function per data source connector. And then through Amazon Athena, you can run a query across Elasticache, DocumentDB, DynamoDB, Redshift, Aurora, SQL Server, MySQL, HBase on the EMR service, or any on-premises database directly from Athena, as well as, of course, Amazon S3. And you can do your joins, and you can do your computations, and so on. That's why it's called a federated query. And then the results of this query can be stored into your Amazon S3 bucket for later analysis. So that's it for Amazon Athena. As you can see, it's a very powerful service. I hope you liked it, and I will see you in the next lecture. Okay, so let's use the Athena service to query our data in Amazon S3 using the SQL query language. So we are getting into Athena, and as we can see, this is the new editor. And so before you run your first query, you need to set up a query result location in Amazon S3. So let's click on View Settings and then Manage. And then here we need to specify a location of query results. So what I have to do is to go into Amazon S3, create a bucket, and I'll call this one Stefan Demo Athena EU Central 1. That should be unique. And then it will create this bucket. Now the bucket is created. I can click on View Details. Here's my buckets. And I can just copy the bucket name right here. And I'm going to just enter S3 : / and then bucket name. Let's click on Save. And now my query result location is going to be in this S3 bucket. So now that we have this done, we can refresh this page. And we can see that there are already some data sources, the Ahrefs data catalog, and some databases we can use, okay? But what I'm going to do is that I'm going to create my own database for it to work. So, because you may not necessarily have this. So for this, it's pretty easy. We're going to query our S3 access logs in Amazon S3. So I've made my bucket called Demo S3 Access Logs Stefan 2020, which contains my access logs in this S3 logs folder. So what I have to do now is to actually create a database and create this table that will represent the objects in here. So how to do so? Well, let's go into our code. And the first line we have under S3 Advanced Athena S3 Access Class.SQL is to create this database. So we'll paste this in, create database, and then click on Run. And this creates a database successfully. So now we have a specific database here called S3 Access Logs DB. Next, we need to create an external table that represents the bucket logs. So let me copy and paste this. And the question is, how did I get this? Well, if you type Athena S3 access logs on the internet, you will have a link, and this link will actually give you the query you need to do to create these proper access logs. So the one thing I have to change is under the location, we need to change the target bucket name and the prefix. Well, it turns out that my properties will give me this. So I'll copy this S3 URI, which has the bucket name and the prefix. So I will paste this in right here, and we're good to go. Now let's run this. And now the query is successful. So now under this database, you see there is a table called My Buckets Logs with a bunch of columns. So if I click on this and click on Preview Table, now this is going to run a select star from my table, limit 10. And at the bottom, we see that it returns 10 rows, okay? And these 10 rows represent my access logs. So this is super handy. Now I get all my access logs data in this table. Super, super handy. So this is just scratching the surface, because now using Athena, we can run some more interesting types of queries. So as we can see right now, we have done nothing. We didn't set up any database per se. We didn't provision database. This is all serverless, okay? All these queries are run by the Athena service directly on the data that sits within our S3 buckets, which is, I think, extremely powerful. So in this query, we're going to say we want to get the request URI operation, the HTTP status, count start to count how many from this table, and we're going to do a group by. So this is a more advanced SQL query, but it's going to give us a little report of the status codes as well as how many times they occurred. So we can see, for example, that a get 404 happened 49 times, and a head 200 happened 81 times, and so on. Or get 403 happened 14 times. So this could help us, for example, do a report into visioning what types of queries or what types of requests do not happen or do not succeed on our buckets. So super handy. And one last, for example, we saw that there were a few 403 errors. So we can say, hey, this is when it's unauthorized. This is very fishy. Either someone is not authorized to do something and cool, we want to know who and why, or someone is trying to get unauthorized access to our buckets and we want to just deep dive into it. it. So again, we run this query, and then we have 44 rows, which are not present here because the data is probably very, very big. But we have 44 rows, okay? And these rows will represent what type of query generated and ended up in a 403, which is super handy. So again, the whole power here of Athena is that we're able to literally query data on Amazon S3, do some complex queries directly without setting up any servers, without transforming our data, just by setting up the right data formats and specifying what the data is. Athena is able to help us with all these things, okay? Finally, in Athena, you can see the recent queries as well as saved queries if you wanted to, and edit the settings if you wanted to encrypt the query results in the target buckets. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about Amazon Redshift, which is a database, but also an analytics engine. So Redshift is based on the PostgreSQL technology, but instead of Postgres, it's not used for online transaction processing. It's actually an all-app type of database, which means online analytical processing. And it's used for analytics and data warehousing. So it has a 10x better performance than any other. data warehouses out there, and it scales to petabytes and petabytes of data. So the idea is that you would load all your data into Redshift, and then very quickly you can analyze it from within Redshift. So the Redshift has good performance improvements because it's actually using a columnar storage of data, so instead of row-based, and it has a parallel query engine. You pay as you go for all the instances you provision in your Redshift cluster, and to perform your queries, you can use just directly some SQL statements. So any business intelligence tool such as Amazon QuickSights or other ones such as Tableau integrate with Redshift. And so if you had to compare Redshift and Athena, Redshift, first you have to load the data, sometimes from Amazon S3, but you have to load all the data into Redshift. And then Redshift versus Athena, well, if it's loaded in Redshift, Redshift is going to have much faster queries. Also, Redshift can do much faster joins and much faster integration because Redshift actually has something that Athena does not have. Redshift has indexes and it builds indexes to have this very high performance for a data warehouse. So if it's just an ad hoc query on Amazon S3, then Athena is going to be a great use case. But if it's like intense data warehousing with many queries and they're complicated, they're joins, aggregations, and so on, then Redshift is going to be a better candidate. So your Redshift cluster has two things. It has leader nodes, and they do query planning and results aggregation. And then it has compute nodes, and they actually perform the queries and they send back the results to the leader. And because it's a Redshift cluster, you have to provision the node size in advance. And if you wanted to do, therefore, cost saving, you could use reserved instances. So your Redshift cluster has a leader node and then some compute nodes, and then you would submit a query in the SQL form. to the leader node, and the query would happen in the backend. So this is it for an overview of Redshift. So let's talk about snapshots and DR. So Redshift is single AZ for most clusters, but now there's a multi-AZ mode for some cluster types. And so if you have multi-AZ, then you're good for disaster recovery. But if you have single AZ, then to do disaster recovery, you need to use snapshots. So snapshots are point-in-time backups of a cluster, and they will be stored internally in Amazon S3. And they are incremental. Only what has changed will be saved. And that will save you a lot of space, obviously. You can restore a snapshot into a new Redshift cluster. And you have two modes for snapshots. You can take them manually, or you can take them in an automated way. So if you automate it, every 8 hours there's going to be a snapshot, or every 5 gigabytes on the schedule. And then you can set the retention for your automated snapshots, or if you want to do a manual snapshot, the snapshot is going to be retained until you delete it manually. And then a really, really cool feature of Redshift is that you can configure Redshift to automatically copy snapshots, whether they're automated or manual, of the cluster into another AWS region, hence giving you a disaster recovery strategy. So let's take this Redshift cluster, your original cluster, and then we have another region. So we're going to take snapshots. They're going to be automatically copied into your new region, and from there you can restore a new Redshift cluster from that copied snapshots. Now let's talk about how we ingest data into Redshift. So we have 3 ways I'm going to describe about how we ingest data into Redshift to describe to you. Now let's talk about how we ingest data into Redshift. So we have 3 ways I'm going to describe to you. The first one is to use Amazon Kinesis Data Firehose. So we have Firehose that will be receiving data from different sources, and then it will send it into Redshift. And to do so, it will first write the data into an Amazon S3 bucket, and then Kinesis Data Firehose will issue automatically an S3 copy command to load the data into Redshift. Now, how does this copy command work? We can also use it manually. So you would load data into S3, and then you would issue a copy command directly from Redshift to copy data from an S3 bucket using an IAM role into your Amazon Redshift cluster. And as we've seen, there are 2 ways of doing so. You might go through the internet because your S3 buckets are public through the internet. I mean, they're not public, but they're connected to the internet. And so therefore, you're going to have your data flow through the internet back into your Redshift cluster. And this is without enhanced VPC routing. But if you wanted all your network to remain private into your virtual private cloud, then you can enable enhanced VPC routing to have all the data flow through the VPC entirely. And finally, if you wanted to insert data using the JDBC driver into the Redshift cluster, you could do so as well. So for example, if you have an application, an EC2 instance that needs to write data into your Redshift cluster, you would need to use this method. And in that case, it is much better to write large batches of data into Amazon Redshift instead of one row at a time, which would be truly inefficient for this type of database. So a cool feature of Redshift is Redshift Spectrum. The idea is that you would have data in Amazon S3 and you want to analyze it using Redshift, but you don't want to load it into Redshift first. And on top of it, you want to use a lot more processing power. So you use Redshift Spectrum, and you must have a Redshift cluster already available to start the query. And then once you start the query will then be submitted to thousands of Redshift Spectrum nodes that will perform the query onto your data in S3. So let's go for an example. You have your Redshift cluster with a leader node and a bunch of compute nodes, as we've seen. And the data you want to analyze is in Amazon S3. So in this case, we're going to run a query onto our Redshift cluster. As you can see, what we want to do is that the table we want to query is living in S3. So we have from S3 dot and whatever you want. In that case, Spectrum will launch automatically. And so the query is going to be submitted to thousands of Redshift Spectrum nodes who are going to read the data from Amazon S3 and perform some aggregations. And when they're done, they're going to send back the results into your own Amazon Redshift cluster, and then you will get back into whoever initiated the query. But with this feature, we can leverage a lot more processing power from Redshift than the one we have provisioned into our cluster without, in the first place, loading the data from Amazon S3 into Redshift. So that's it for Amazon Redshift. I hope you liked it, and I will see you in the next lecture. So now let's talk about the Amazon OpenSearch service. And Amazon OpenSearch is a successor to something you may have heard before called Amazon Elasticsearch. So the name change was due to some licensing issues. So in DynamoDB, just to do a comparison, you can only query the data by primary key or if you have indexes on your database. But with OpenSearch, you can actually, as the name indicates, search any fields, even for partial matches. So it's very common to use OpenSearch to provide search to your application. application. And so you would use OpenSearch as a complement to another database. So OpenSearch can be used for search, but also, as the name doesn't indicate, you can also do analytic queries on top of OpenSearch. So you have two modes to provision an OpenSearch cluster. Either you use the manage cluster option and then actual physical instances will be provisioned for you and you will see them. Or you can go the serverless route and have a serverless cluster where everything from scaling to operations is handled by AWS. And OpenSearch has its own query language. It does not natively support SQL, but you can enable SQL compatibility via a plugin. So you can ingest data from different places, such as Kinesis Data Firehose, IoT, CloudWatch Logs, or any of your custom-built application. You have security provided through integration with Cognito, IAM, you get at-rest encryption and in-flight encryption. And as I said, you can do analytics on top of the OpenSearch service, so you can use something called OpenSearch dashboards to create visualizations on top of your OpenSearch data. So here are some common patterns to use OpenSearch. So you would have DynamoDB and it would contain your data. This is where your users would insert and delete and update data. And then you send all the streams in a DynamoDB stream, which is then picked up by a Lambda function. And that Lambda function will insert the data into Amazon OpenSearch in real time. And through this process, what happens is that your application now has the ability to search for a specific item, for example, to do a partial search with the item name, and then find the item ID out of it. And then once the item ID is obtained, then it will call DynamoDB to actually retrieve the full item from your DynamoDB table. So that's a common pattern in which OpenSearch provides the search capability, whereas your main source of data still remains your DynamoDB table. There's also other ways. So you can ingest CloudWatch logs into OpenSearch. So the first one is to use what's called a CloudWatch log subscription filter, sending data in real time to a Lambda function that is managed by AWS. And then the Lambda function in real time sends all the data into Amazon OpenSearch. Or you can also use a CloudWatch logs and then subscription filter. But this time, Kinesis Data Firehose can read from this subscription filter. And then near real time, because this is Data Firehose, data will be inserted in Amazon OpenSearch. Other patterns around Kinesis. So to send Kinesis data streams into Amazon OpenSearch, you have two strategies. The first one is to use Kinesis Data Firehose. This is a near real time, again, type of service. You can optionally do some data transformation using a Lambda function and then send data into Amazon OpenSearch. Or you can use Kinesis data streams again, but this time you would create a Lambda function that would read the data stream in real time, and then you would write custom code to have the Lambda function write to Amazon OpenSearch in real time. So all these patterns are valid, and now you know pretty much all the possible architectures for using Amazon OpenSearch. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Now let's talk about Amazon EMR. So EMR stands for Elastic MapReduce, and EMR helps you create Hadoop clusters for doing big data on AWS. And this allows you to analyze and process vast amount of data. So anytime you would see anything related to big data clusters with Hadoop clusters, then think Amazon EMR. So these clusters have to be provisioned, and they can be made of hundreds of EC2 instances. And why would you use EMR? Well, EMR comes bundled with a lot of tools that a big data specialist use. For example, Apache Spark, or HBase, or Presto, or Apache Flink. And they're very difficult to set up, and so Amazon EMR will take care of all the provisioning and the configuration of these services for you. You can also autoscale your entire cluster, and it's integrated with Spot instances for you to benefit from price reductions. So the use cases of Amazon EMR from an exam perspective are going to be around data processing, doing machine learning, web indexing, and big data, but all of them using big data related technologies such as Hadoop, Spark, HBase, Presto, Flink, and so on. So Amazon EMR is made of clusters of EC2 instances, and you have different kind of nodes. You have the master node, and the master node manages the cluster. It will coordinate and manage the health of all your other nodes, and it must be long running. Then you have the core node. They are here to run tasks and also store data, and they must be long running as well. And then you have this task node, which is there just to run tasks, and usually you can take spot instances for it, and using task node is optional. So the purchasing options really depends. If you have the on-demand EC2 instance type, then you're going to get reliable, predictable type of workloads, and they will never be terminated. If you use reserved instances, and remember it's minimum 1 year of usage, then you're going to get big cost savings, and EMR will automatically use your reserved instances if possible. And therefore, good candidates for reserved instances are going to be the master node, because it must be long running, and also the core nodes. And regarding spot instances, well, because they can be terminated, they're less reliable, but they're cheaper. And so a good way for you to leverage spot instances would be on task nodes. Finally, for EMR, in terms of deployment, you can have either long-running clusters, which would make sense for then using reserved instances, or you can use transient temporary clusters to just do something and then tear it down once the analysis is done. Okay, you know all you need to know for Amazon EMR at the exam. I hope you liked it, and I will see you in the next lecture. Now let's talk about Amazon QuickSight. So Amazon QuickSight is a serverless, machine-powered business intelligence service. And so when you hear business intelligence, that means that you're going to create interactive dashboards. So this is what QuickSight looks like. You can create dashboards, and these dashboards are connected to data sources that you own, and therefore you can create these nice visuals. So it's fast, it's automatically scalable, you can embed it in website, and you get a per session pricing. The use cases for QuickSight are going to be around business analytics, building a visualization, performing ad hoc analysis in a visual fashion, to get business insights using data. And so you can connect to many data sources, as we'll see in the next slide, such as RDS, Aurora, Athena, Redshift, S3, and so on. Now there is something called the SPICE engine. I need to remember it. It's an in-memory computation engine, and it only works if you actually import data directly into Amazon QuickSight. It doesn't work if Amazon QuickSight is connected to another database. And finally, QuickSight has some very nice user level features. And so it's possible in the Enterprise edition of Amazon QuickSight to set up column level security, CLS, to prevent some columns from being displayed for some users if they don't have enough access rights. So what does QuickSight integrate with? Well, you can integrate it with many data sources from AWS. For example, your RDS database, or Aurora, or Redshift, which is a great data warehousing service, or Athena to do ad hoc queries on Amazon S3, or Amazon S3 to actually import data, or OpenSearch, or TimeStream to visualize your time stream data your time series data in an optimized fashion. You can also integrate with third-party data sources that are software as a service and supported by QuickSight. And the full list is on the QuickSight website, but some of them include Salesforce and also Jira. You can also integrate with third-party databases, such as Teradata, or, for example, an on-premises database that is using the JDBC protocol internally. And as I said, you can import data sources directly into QuickSight, such as your Excel files, your CSV file, JSON documents, TSV, or the ELF is CLF format for log format. And if these data sources are imported into Amazon QuickSight, then you can leverage the SPICE engine to perform in-memory computation in a very, very fast way. So that's for the integrations. And you will very commonly see at the exam using QuickSight with Athena or QuickSight with Redshift. But any of these is possible to be seen. Now, you have two things in QuickSight. You have dashboards and analysis. So in QuickSight, you actually have users, which is available in the standard version, and groups of users only available in the enterprise version. And these users and groups, they only exist within the QuickSight service. So they're not equivalent to IAM users. IAM users are only used for administration. And so you define these users and these groups from within QuickSight, and then you create a dashboard. And a dashboard is a read-only snapshot of an analysis that you can share. And it will preserve the configuration of the analysis. So whatever filters, parameters, controls, and sorting options you set on your analysis is going to be preserved and is going to be a dashboard. And so an analysis is more complete, but you can share either the analysis or the dashboard with specific users or groups. And to do so, you must first publish, for example, your dashboards. And then if users have access to the dashboards, they can also see the underlying data. So in QuickSight, you would create your analysis or dashboards, and then you would share it with specified users and groups. And that's it. You know everything there is to know about QuickSight for the exam. I hope you liked it, and I will see you in the next lecture. So now let's talk about AWS Glue. So Glue is a managed extract, transform, and load service, also called commonly ETL service. It's very useful to prepare and transform data for analytics. So this is a fully serverless service, and you're just going to submit whatever you want, and it will achieve it. For example, say you had data in an S3 bucket or an Amazon RDS database, and you wanted to load this into a Redshift data warehouse. So you could extract it using Glue. Then you would transform it if need be to maybe filter some data or add some columns and so on, whatever you want. And then you would load the final output data into a Redshift data warehouse. So all of this happened from within the Glue ETL service. You just have to write some code, launch your ETL job, and off you go. So that's one example. Another example that's going to come up in the exam is how to convert data into the Parquet format. So why would we do this? Because, well, the Parquet format is a columnar data format, and therefore it is much better when in use, for example, with services like Athena. So say, for example, that you are doing inserts into your S3 buckets, and then these files are in the CSV format. Then you would use the Glue ETL service to import the CSV and convert it into a Parquet format from within the Glue service. Then you would send it into an output S3 bucket, and when in Parquet format, then Amazon Athena is going to analyze this file in a much better fashion. So the other thing you can do to automate this entire process is that anytime a file is inserted into the S3 bucket, then you can send event notifications to a Lambda function, which will then trigger a Glue ETL job. But you could replace the Lambda function with Event Bridge as well. This would work as an alternative. Okay, so there's another feature of Glue called the Glue Data Catalog, which is to catalog datasets. So the Glue Data Catalog will run Glue data crawlers, and they will be connected to various data sources, such as these files are in these files are in the CSV format. formats. Then you would use the glue ETL service to import the CSV and convert it into a Parquet format from within the glue service. Then you would send it into an output S3 bucket. And when in Parquet format, then Amazon Athena is going to analyze this file in a much better fashion. So the other thing you can do to automate this entire process is that anytime a file is inserted into the S3 bucket, then you can send event notifications to a Lambda function, which will then trigger a glue ETL job. But you could replace the Lambda function with event bridge as well. This would work as an alternative. Okay, so there's another feature of Glue called the Glue Data Catalog, which is to catalog datasets. So the Glue Data Catalog will run Glue data crawlers, and they will be connected to various data sources, such as Amazon S3, Amazon RDS, Amazon DynamoDB, or a compatible JDBC database that you own on premises, for example. So the Glue data crawler is going to crawl these databases and is going to write all the metadata of your tables, of your columns, of your data types, and so on into the Glue data catalog. And so it will have all the databases, the tables, and the metadata, and that will be leveraged by the Glue jobs to perform ETL. Now also, when you use Amazon Athena, behind the scene to do the data discovery and the schema discovery, Amazon Athena is going to be leveraging the AWS Glue data catalog. So will Amazon Redshift Spectrum, and so will Amazon EMR. So as you can see, the Glue data catalog service is central to many other AWS services. So other features that can appear at the exam on Glue and that you should know at a high level, the first one is Glue job bookmarks. And so this is to prevent you from reprocessing all data in case you run a new ETL job. So this is very important and it can come up in the exam. Then you have Glue Elastic Views, and this is to combine and replicate data across multiple data stores using SQL. So you would, for example, create a view across an RDS database and an Aura database and Amazon S3. So there's no custom code for this, and Glue is going to monitor for changes in the source data, and it's going to be serverless. So this way you will create a virtual table, which is a materialized view that spreads across multiple data stores. You have Glue Data Brew, which is used to clean and normalize data using pre-built transformation. You have Glue Studio, which is a GUI to create, run, and monitor ETL jobs in Glue. And then you have Glue Streaming ETL, and it's actually built on top of Apache Spark structured streaming. And it's instead of running ETL jobs as batch jobs, you can run them as streaming jobs. And so therefore you can read data using Glue Streaming ETL from Kinesis data streams or Kafka or MSK, as we'll see, which is Managed Kafka on AWS. Okay, so that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about AWS Lake Formation. So AWS Lake Formation helps you create data lakes, but what is a data lake? Well, a data lake is a central place to have all of your data in one place so that you can do analytics on top of it. So Lake Formation is a fully managed service that makes it super easy to set up a data lake. And usually that can take months, but thanks to Lake Formation, it takes just a few days to get started with a data lake. So Lake Formation will help you discover, cleanse, transform, and ingest data into your data lake. And it automates many complex manual steps, such as the collecting, cleansing, moving, cataloging data, and also any kind of deduplication. For this, it uses machine learning transforms. So in this data lake, you can combine structured and unstructured data sources, and it has blueprints. So blueprints come out of the box, and they help you migrate data from one place to this central data lake. So it has blueprints for Amazon S3, Amazon RDS, or your relational databases that you run on premises, or your NoSQL databases, and so on. And why do you set up Lake Formation? Well, you have everything in one place, but on top of it, you can have fine-grained access controls for your applications at the row and the column level. That means that any application that is connecting to the AWS lake formation will have fine-grained access control. And this is a huge plus, and we'll have a look at it in a few slides. So how does lake formation work? Well, it's actually a layer on top of AWS Glue, but you don't actually interact with Glue directly. So, as I said, lake formation allows you to create a data lake that is stored in Amazon S3. And the data sources could be Amazon S3, RDS, Aurora, your on-premises database such as SQL or NoSQL. Anyways, and thanks to the blueprints available on lake formation, you will ingest the data. So lake formation comes with source crawlers, it comes with ETL and data preparation tools, and data cataloging tool, and all of this comes from the underlying Glue service. Then we have security settings and access controls to make sure that your data is protected on your data lake. And then services that can leverage lake formation can be Athena, Redshift, EMR, or other analytics tools such as, for example, the Apache Spark framework. And so you as users, you are connecting to these services, which are in turn connecting to lake formation and your data lake. So why do we want to use lake formation? Well, one central key aspect that is definitely mentioned at the exam is around the centralized permissions. So say, for example, that your company is using Athena and QuickSight to analyze data, and your users must only view the data they need, and they should have permissions to see. And your data sources include Amazon S3, RDS, Aurora, and so on. So you could try to set up security in Athena, or you could try to set up security in QuickSight, or at the user level, or you can set up security with S3 bucket policies, or with users and so on in RDS, or in Aurora. And so you have multiple places where you can manage security and it becomes a mess. What is the right thing, right? So lake formation solves this problem because you have access control and you get column and row level security. So with lake formation, again, you ingest all this data. It sits in a central S3 bucket, but from within lake formation, you actually manage all the access control for row and column level security. So that any service that then connects to lake formation only will have the right to see whatever has the right to see. So if you use Athena, if you use QuickSight, if you use whatever other tools, and you connect to lake formation, you manage the security in one place, and that is lake formation. And that is a big advantage, and that you will see at the exam. Okay, so that's it for lake formation. I hope you liked it, and I will see you in the next lecture. Formation.
Hi guys, we are just going to click. So for us to be able to Windows Shift S, and then we are just going to drag this one. So as you can see, this will pop out and you're just going to click that there. So once you're okay with that, you can also adjust this by cropping the picture. Once you're good to
formation only will have the right to see whatever has the right to see. So if you use Athena, if you use QuickSight, if you use whatever other tools, and you connect to lake formation, you manage the security in one place, and that is lake formation. And that is a big advantage, and that you will see at the exam. Okay, so that's it for lake formation. I hope you liked it, and I will see you in the next lecture. So now let's talk about Kinesis data analytics. And there are two flavors of it. There's the first one for SQL applications and the second one for Apache Flink. So let's first talk about the first kind, which is Kinesis data analytics for SQL applications. So it sits in the center, and the two data sources that it's able to read from are Kinesis data streams and Kinesis data firehose. So you can read from either of those, and then you can apply SQL statements to perform your real-time analytics. It's also possible for you to join some reference data by referencing it from an Amazon S3 bucket. This will, for example, allow you to enrich the data in real time. Then you can send data to various destinations, and there are two of them. The first one is a Kinesis data stream. So you can create a stream out of a Kinesis data analytics real-time query, or you can send it directly into Kinesis data firehose, each with their own use cases. If you send directly into Kinesis data firehose, then you can send into Amazon S3, Amazon Redshift, or Amazon OpenSearch, or any other firehose destinations. Whereas if you send it into a Kinesis data stream, you can do real-time processing of that stream of data using AWS Lambda or whatever applications you are running on EC2 instances. So remember this diagram. This is for Kinesis data analytics for SQL application. Now, if we go into the details, as I said, the two sources are only Kinesis data streams and firehose. You can enrich using data from Amazon S3. It's a fully managed service. You don't provision any servers. There is automatic scaling, and you actually pay for whatever goes through Kinesis data analytics. In terms of outputs, as I said, you can go into Kinesis data streams or Kinesis data firehose. And the use cases would be to do time series and analytics, real-time dashboards, or real-time metrics. So that's for the first kind of Kinesis data analytics. The second one is Kinesis data analytics for Apache Flink. So as the name indicates, you can use actually Apache Flink on the service. And so if you use Flink, you can write your application using Java, Scala, or even SQL to process and analyze streaming data. So you may say, well, that's the same thing, isn't it, from before? And it's not. So Flink are special applications you need to write as code, okay? And what it allows you is that you can actually run these Flink applications on a cluster that's dedicated to it on Kinesis data analytics, but it's all behind the scenes. And with Apache Flink, you can read from two main data sources. You can read from Kinesis data streams or Amazon MSK. So with this service, you run any Flink application on a managed cluster on AWS. And the idea is that Flink is going to be a lot more powerful than just standard SQL. So if you need advanced querying capability or to read streaming data from other services such as Kinesis data streams or Amazon MSK, which is managed Kafka on AWS, then you would use this service. So with this service, you get automatic provisioning of compute resources, parallel computation, and automatic scaling. You get application backups. They're implemented at checkpoints and snapshots. You can use any of the Apache Flink programming features. And just so you know, with Flink, you can only read from Kinesis data streams and Amazon MSK. You cannot read from Kinesis data firehose. If you need to read and do real-time analytics on Kinesis data firehose, then you must use Kinesis data analytics for SQL. Okay, so that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So here I am in the Amazon Kinesis service, and I want to show you just the options for Kinesis data analytics. So here it is. So we have two different kinds of things. You can either create a streaming application or go into the studio. So the streaming application is actually just all leveraging Apache Flink. So this is the Kinesis data analytics for Apache Flink. You choose a runtime version for Apache Flink that's supported, and then you can have the application name, and then at some point you need to enter your production information, and this would create a streaming application that you can use on AWS. And so you would need to actually upload then your application here. So as we see when we get there, and we don't have any Apache Flink application available to us because this is quite complicated to write, then you can run and you can even monitor it using the Apache Flink dashboard. So this service is to create Apache Flink applications. And actually, if you wanted to just do one-off analysis, you can open a Studio notebook, and this will just quickly create a notebook where you can start running your streaming applications, again, leveraging Apache Flink. Okay, so this I will not do. And then where is the Apache, where is the Amazon Kinesis Data Analytics for SQL applications? Well, it's on the left-hand side, and this is where it would be. So you would find it under the SQL applications legacy. And now they recommend that you use all the time Kinesis Data Analytics Studio and Apache Flink. But if you wanted to, for example, read from Kinesis Data Firehose, you would create a SQL applications in the legacy form, and you would enter actually the application name. And I did create one. And then once you've defined your application name, you can actually go to real-time analytics and write the kind of SQL you want to do for this application, okay? So it's just an overview. You don't need to know anything about Kinesis Data Analytics for this exam, but I want to show you the options, to give you a quick introduction, and so you could visualize it as well on the console. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Another analytics service you will see is Amazon Managed Streaming for Apache Kafka, also called Amazon MSK. And what is Kafka? Well, Kafka is an alternative to Amazon Kinesis. Kafka and Kinesis both allow you to stream data. So MSK is the ability to get a fully managed Kafka cluster on AWS. And it allows you to create, update, and delete clusters on the fly. And MSK is going to create and manage Kafka broker nodes and Zookeeper broker nodes in your cluster for you. And you deploy the cluster in your VPC across multiple AZ, up to 3 for high availability. You also have automatic recovery from common Kafka failures, and the data is stored on EBS volumes for as long as you want. So from personal experience, I know it's very difficult to set up Apache Kafka, and the fact you can just do one click and then deploy Kafka on AWS is great. And this is the Amazon MSK service. So on top of it, you have the option to use MSK serverless. And this is that you run Apache Kafka on MSK, but this time you don't provision servers, you don't manage capacity. Automatically, MSK will provision resources and scale compute and storage for you. So what is Apache Kafka then? Apache Kafka is a way for you to stream data. And a Kafka cluster is made of multiple brokers, and then you will have producers that will produce data, and so they will have to ingest data from places such as Kinesis, IoT, RDS, etc., etc., and they will send the data directly into a Kafka topic that is going to be fully replicated into other brokers. Now, this Kafka topic is having real-time streaming of data, and consumers will pull from the topic to consume the data itself, and then your consumer can do whatever he wants, process it, or send it to various destinations such as EMR, S3, SageMaker, Kinesis, and RDS. So the idea is that Kafka is quite similar to Kinesis, but there are differences to look out for. So what are the differences between Kinesis data streams and Amazon MSK? Well, in Kinesis data streams, you have a 1 megabyte message limit, which is the default in Amazon MSK, but you can configure it for a higher message retention, for example, 10 megabytes. You can have data streams with shards in Kinesis data streams, or in MSK, it's called Kafka topics with partitions, but the concepts are sort of similar. To scale a Kinesis data stream, you need to do shard splitting, and to scale it down, merging. But in Amazon MSK, to scale a topic, you can only add partitions. You cannot remove partitions. You have in-flight encryption for Kinesis data streams, and then you have either plain text or TLS in-flight encryption for MSK. You get at-rest encryption for both of these clusters, and at the exam level, this is enough. Just so you know, a few differences, and also for Amazon MSK, you can keep data for as long as you want. You can go over 1 year. As long as you pay for the underlying EBS storage, you're good to go. So to produce to MSK, you need to create a Kafka producer, and then to consume from MSK, you have multiple options. The first one is to use Kinesis Data Analytics for Apache Flink. So you run a Flink application and you make it read directly from the MSK cluster. You can use Glue as well to do streaming ETL jobs, and they're powered this time by Apache Spark Streaming. You can use Lambda functions to directly have Amazon MSK as an event source, Or you can write your own Kafka consumer and you can make it run on whatever platform you want. For example, your Amazon EC2 instances, or an ECS cluster, or an EKS cluster. And once you know this, you know pretty much everything there is to know for Amazon MSK at the exam. So I hope you liked it, and I will see you in the next lecture. Okay, so now let's talk about another architecture for big data ingestion pipeline. So ideally, we want the application ingestion pipeline to be fully serverless, fully managed by AWS, and we want to collect data in real time. We want to transform the data. We want to query the transformed data using SQL, and the reports we create using these queries, maybe they should be stored in S3, and then we want to load that data into a data warehouse and create dashboards on it. So overall, the usual big data problems of ingestion, collection, transformations, querying, and analysis. Okay, so how do we do this? And there are some technologies we may not have seen them directly in this course, but that's okay. I'll just introduce them to you in this pipeline because they really help. So IoT devices. So let's assume that the producers of data are IoT devices. And so there is this really cool services in Amazon Cloud Services, and it's called IoT Core. And IoT Core helps you manage these IoT devices. So remember this if you go into the exam. Now, these devices can send data in real time to IoT Core, and IoT Core directly into a Kinesis data stream. So data stream for Kinesis, remember, it allows us to basically pipe big data in real time very fast into this Kinesis service. Now, Kinesis can be talking to Kinesis data Firehose, and Firehose allows us to, for example, every 1 minute, put and offload our data into an Amazon S3 bucket, and that will be an ingestion bucket. So here, what we've done here is that we've just had a whole pipeline to get a lot of data from a lot of devices in real time and put it every 1 minute into an S3 bucket. On top of it, it's possible for us to cleanse or really quickly transform the data using an AWS Lambda function that is directly linked to Kinesis data Firehose. Okay, so now we have that ingestion bucket. What can we do with it? Well, for example, we can trigger an SQS topic, an SQS queue, sorry, and it's optional. And maybe the SQS queue can trigger an AWS Lambda function. I say optional because Lambda can be directly triggered by our S3 bucket, but I just wanted to show you the possibility of invoking SQS through that slide. Okay, so Lambda, what will it do? Well, Lambda will trigger an Amazon Athena SQL query, and this Athena query will pull data from the ingestion bucket, and we'll do an SQL query that's all serverless, and the output of this serverless query will go into a reporting bucket, maybe again in Amazon S3 be a different bucket. Okay, so from this we have the data, it's being reported on, it's being cleansed and analyzed. We can either directly visualize it using QuickSight. So QuickSight is a way for us to visualize our data into an Amazon S3 bucket, or we can load the data into a proper data warehouse for analytics, such as Amazon Redshift. And so this Redshift data warehouse can also serve as an endpoint for QuickSight. But this shows you overall what you can expect in a big data ingestion pipeline at a high level, including real-time ingestion, transformation, serverless, Lambda, and some data warehousing using Redshift, and visualization using QuickSight. So let's discuss about this pipeline. IoT Core allows you to harvest many data from many IoT devices. Kinesis is great for real-time data connection, and Firehose helps you with data delivery to S3 in near real time. So 1 minute is the lowest frequency you can choose. Lambda can help Firehose with data transformation, and then Amazon S3 can trigger notifications to SQS, SNS, or Lambda. Lambda can subscribe to SQS, but we could have, as I said, connected S3 to Lambda. And Athena is a serverless SQL service, and we can store the results of Athena directly back into S3. And the reporting buckets contain analyzed data, and we can use reporting tools such as QuickSight for visualization or Redshift if you want to do more analytics on it. So that's it for a big data ingestion pipeline, but at a high level, from a solution architecture perspective, it's really good to know how all these things work. I hope you like this, and I will see you in the next lecture. So now let's talk about Amazon Recognition. And recognition is a service used to find objects, people, text, scenes in images and videos using machine learning. So it can do facial analysis and facial search to do user verification and count how many people there are in an image, for example. Or you can create your own database of familiar faces, or you can compare against a database of celebrities to find people in your images as well. So the use cases for recognition is to take your image and do labeling, images and video, and to do labeling, content moderation, text detection, face detection and analysis. For example, find the gender, the age, range, and the emotions that are associated with these faces. Do a face search and verification. Do celebrity recognition, as well as pathing. So, for example, if you're doing a sport game analysis of a video. So that's a high level. Remember, recognition is about images and videos. So on the recognition website, we can see we can automate our image and video analysis with machine learning. And I really like this website because it shows you how it works. So for example, for this image, we can identify the elements of this image. So for example, a person, a rock, a mountain bike, a crest, and outdoors. We can label, for example, what we see in the images, for example, golden retrievers or dogs. Then I can look at content moderation to make sure that it's appropriate for all ages. I can detect text, for example, for a run, we want to see the numbers of each runner in the run. We can do face detection and analysis. For example, this person looks happy, she is smiling, her eyes are open, and she's a female. Face search and verification, maybe if you have a security application. Finally, if you want to recognize celebrity, you can take a picture of them, and this is the CTO of AWS. And then finally, pathing. For example, if you're monitoring a soccer game, you could see where everyone is going to do maybe some real-time analytics. And there's one feature you need to know about going into the exam. It's around content moderation. So this is used to detect content that is inappropriate, unwanted, or offensive in images and videos. So this would be used, for example, if you have a social network, or if you broadcast media, or if you do advertising, or if you're doing e-commerce and you need to create a safe user experience and make sure the images displayed don't show any kind of content that would be deemed offensive by some people. For example, racist content or pornography or other kind of things like this. So how does that work? Well, the image will be analyzed by Amazon Recognition, and then you set a minimum confidence threshold for items that will be flagged. So you set it to whatever percentage you want, and obviously the lower you set this percentage, the more matches you're going to get. And this confidence percentage represents how confident Amazon Recognition is that this flagged image represents indeed some inappropriate or offensive character. And then once you have done this and you flagged some images, you may want to do a human manual review. And so to do so, you can use something called Amazon Augmented AI, called A2I, and you do optional manual review directly in Amazon A2I. And all of this process right here allows you to automatically flag images that can be sensitive, and then use a final manual review to know whether or not you want to keep them or delete them. And this can help you with comply with regulations in case you must detect these kind of content before they're posted to your applications. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's talk about Amazon Transcribe. So as the name indicates, it allows you to automatically convert speech into text. So you pass in some audio and automatically it's going to be transcribed into text. So you could say, hey, hello, my name is Stefan and I hope you're enjoying the course. Now, how does it do it? Well, it uses a deep learning process called the ASR, the automatic speech recognition, to convert speech to text very quickly and accurately. And there are a few features you need to know about. The first one is that you can automatically remove any PII, so personally identifiable information, using redaction. So that means, for example, if you have someone's age or name or social security number, this can be automatically removed. And also, you can have access to automatic language identification for multilingual audio. So if you have some French and some English and some Spanish, Transcribe is smart enough to recognize all of those. So the use cases for Amazon Transcribe is to transcribe customer service calls, to automate closed captioning and subtitling, and also to generate metadata for media assets to create a fully searchable archive. So let's have a look at Amazon Transcribe. So I can create a transcript and I can see that the specific language right now is set to English US. So now if I click on start streaming, hello, I really like this course. As you can see, the outcome of the audio get directly transcribed into some text. So that's pretty cool, right? Also, you can have the setting to remove some content and you can remove PII identification. So I could say, hey, you can identify and redact it to remove it. And these are the kind of things that can be removed. So for example, let's have an example and try it out. So I won't show this alert again. Hello, my name is Stefan. I am 31 years old and my phone number is 910-747-280. And as you can see now, the things got hidden. So my name is hidden and my phone is hidden. Obviously, this was not my real phone number. You cannot try it. Okay, and last thing I want to show you is that you can actually stream into multiple languages. So you have automatic language identification. So I would choose English and French. And then let's start again. Hello, this is some recognition happening in English. Bonjour, maintenant je parle en français, c'est ma langue maternelle. Pretty awesome, right? Well, that's it for Amazon Transcribe. If you wanted to play some more, you can have a look at all the options in the bottom. But that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Poly is the opposite of transcribe. You turn text into speech using deep learning. This allows you to create applications that will talk. For example, it says, hello, my name is Stefan, and this is a demo of Amazon Poly. And then with Poly, it would generate an audio, which I can play right here.
Hi, my name is Stefan and this is a demo of Amazon Poly.
I think I'm better at speaking than that, but this gives you a good demo, right? And you can play with it on the console. So Amazon Poly can do more. It can use lexicon and SSML. So the first one is to customize the pronunciation of words with pronunciation lexicons. For example, if there is a stylized word such as Stefan, but the E is a 3 and the A is a 4, the Amazon Poly might say ST3PH4NE, which is not how it should be pronounced. It should be pronounced Stefan. And so therefore, you can create a lexicon for this. Or for example, for acronyms. For example, anytime it sees AWS, instead of saying AWS, it should say the full Amazon Web Services. So then you upload the lexicons and you use them in the synthesize speech operation. The second feature you need to know about is the SSML feature, which is called Speech Synthesis Markup Language. And this enables more customization to how speech is made. So you can, for example, emphasize on specific words or phrases, or you use phonetic pronunciation, or you want to include breathing sounds or whispering, or you want to use the newscaster speaking style. So all of it can be used using this markup language. And so instead of generating the speech from plain text, you can include a whisper and it will start whispering and so on. Okay? So remember, for pronunciation of stylized words or acronyms, use pronunciation lexicons. And for more customization on how words are being pronounced, for example, whispering or phonetic pronunciation and so on, then use the SSML markup language. So if I go into the Amazon Poly service, this is where I can turn text into lifelike speech. So we can try it. So we can use, for example, the neural network, okay? And this is the most natural and human-like speech possible. And we can choose the voice we want. So here's the text. So I will say, hey, my name is Stefan and I love AWS. Let's see what happens. So if we listen to this, it will say,
Hi, my name is Stefan and I love AWS.
so that's pretty cool, right? And here with SSML, and so for example, let's add a break. So I will say, hey, my name is Joanna. And then I open a break. I say break time equals, and this is part of the SSML language. And then slash and end this. So say, hey, break this for 3 seconds. So it will say,
Hi, my name is Joanna.
Now there's a break.
I will read any text you type here.
And this is how you control the speech itself using the SSML markup language. And lastly, if we want to say, hey, I love AWS right here. So we say, I love AWS, and we'll just have 1 second of break. Let's listen to this.
Hi. My name is Joanna. I love AWS.
Okay. What if you want to say not AWS, but Amazon Web Services, in which case you would need to go into additional settings and then customize pronunciation. And here you would need to apply a lexicon and upload a lexicon to convert AWS into Amazon Web Services. So trust me, you just need to create a file and then upload it, create a lexicon, and then automatically, whatever you say, for example, whenever it will find AWS, it will just say Amazon Web Services. And that's it for Amazon Poly. You should know everything there is to know for the exam. I hope you liked it, and I will see you in the next lecture. Now let's talk about Amazon Translate. So Translate, as the name indicates, is a natural and accurate language translation. Translate allows you to localize content, for example your websites and your application, for your international users, and easily translate large volume of text efficiently. So for example, say in English I say hi, my name is Stéphane. In French it would be bonjour, je m'appelle Stéphane. In Portuguese it would be oi, o meu nome é Stéphane. And in Hindi it would be hey, mera naam Stéphane hai. Okay, I just showed off. So that was it. Super easy service. I hope you liked it, and I will see you in the next lecture. So now let's discuss Amazon Lex and Connect. So Amazon Lex is the same technology that powers the Alexa devices by Amazon. And if you don't know Alexa, Alexa is like a little device that you have in your home, and you say, Alexa, what's the weather like tomorrow? And it will reply, hey, the weather is good, it'll be 24 degrees, and it'll be sunny. So the idea is that with Amazon Lex, you get automatic speech recognition, so ASR, that allows you to convert speech, so spoken words, into text. There's also a very good thing because Lex understands the intent of text colors by doing natural language understanding. So it understands sentences. And Amazon Lex is a technology that will help you build chatbots or call center bots. And talking about call centers, how do we build a call center? We have Amazon Connect. So Amazon Connect is a virtual contact center that allows you to receive calls, create contact flows, and it's all cloud-based. And it can integrate with other customer relationship management systems, so CRMs, or AWS services. And the cool thing about Amazon Connect versus traditional offering is that there's no upfront payment. It's about 80% cheaper than traditional contact center solutions. So the whole flow of building a smart contact center is that you will have, for example, a phone call to schedule an appointment that is made into a number that is defined by Amazon Connect. So they call Amazon Connect. Lex is streaming all the information from this call and understand the intent of the phone call. And therefore, it will invoke the right Lambda function. And that Lambda function, for example, can be very smart and say, hey, someone has said to schedule a meeting tomorrow with Tom at 3 p.m. Okay, I will go into my CRM and schedule that meeting by writing some code. So this is the whole idea behind Lex and Connect. So remember, Lex is for ASR and Connect is for contact centers. So that's it. I hope you liked it, and I will see you in the next lecture. Now, Amazon Comprehend is a very simple service from an exam perspective. All you need to know is that comprehend is to comprehend stuff, so it is for natural language processing, or NLP. So anytime you would see NLP at the exam, you would think Amazon Comprehend. Now what it is a fully managed and serverless service, and it will use machine learning to find insights and relationships in your text. For example, it can understand what is the language of the text. It can extract key phrases, places, people, brands, or events from that text. It can do a sentiment analysis to understand how positive or negative the text you're analyzing is. It can also analyze the text using tokenization and parts of speech, so it also has audio. And finally, it can organize a collection of text files by topic and find the topics itself. So Comprehend is really about getting a lot of data in, and then Comprehend will do the rest to try to understand the meaning of that data. So it's about taking text or unstructured data and structuring it around these features. So some simple use cases of natural language processing, or NLP, are, for example, to analyze customer interaction. So say you have a bunch of customers sending you emails and you want to understand overall, based on your support service, what leads to a positive or negative experience from your customers. So we use Comprehend to extract these features, and then you would have a business insight, and then you can improve your business thanks to that analysis. You can also, for example, create and group articles by topics that Comprehend will uncover. So imagine you have a lot of articles and you wanted to group them together. Instead of going to them by one, you would feed them into Comprehend, and then it would output you the topics you need to group them by. So that's it. So again, a bit more information than what you need, but Comprehend from an exam perspective is for natural language processing. So I hope you liked it, and I will see you in the next lecture. So now let's talk about Amazon Comprehend Medical. So Comprehend Medical detects and returns useful information in unstructured clinical text. For example, if your doctor is taking notes, or if you have discharge summaries, or test results, or case notes, then it will use NLP, so it will use natural language processing, to detect all the protected health information within the document itself as well, with the Detect PHI API. So from an architecture perspective, you would store whatever documents you have in Amazon S3, and then you would invoke the Comprehend Medical API. Or you could have Kinesis Data Firehose and then analyze that in real time. Or you can use Amazon Transcribe to first transcribe the voice into text, okay, as we saw from before, and then once it's in text form, we can pass it to the Amazon Comprehend Medical service. So let's have a look into the console to see how that works. So I am in the Amazon Comprehend Medical service, and let's launch a real-time analysis. So here is input text, and so imagine that this is doctor's note, and he wrote or she wrote all these things, right? So the doctor, okay, wrote all this. Now let's analyze it, and from this we can have entities, and so you can find an age and a high school teacher, and then you can find some overlap between some things, such as there was a procedure name and the time to the procedure name and the date and so on. As you can see, all this data become quite organized, and so you have like some generic name of a molecule and its strength and dosage and root modes and frequency and so on. And this allows you to really start structuring all your health data from unstructured text using machine learning. So you can explore this, okay, but I'm not going to go into the details of this. This is a medical field that I'm not very confident with, but at least you know that thanks to Amazon Comprehend Medical, you can take information in text form and then get insights out of it. So I hope you liked it, and I will see you in the next lecture. Okay, so now let's talk about Amazon SageMaker. So SageMaker is a fully managed service for developers and data scientists to build machine learning model. So all the services so far we've seen in this section, they're all managed machine learning service with a very specific purpose. For example, translate some text, transcribe some audio, or convert text into audio, or analyze parts of the text. But SageMaker is a higher level machine learning service where you have your actual developers or your data scientists within your organization create and build machine learning model. So it is a lot more involved and a lot more difficult to use. Now, when you want to do these kind of processes to build a machine learning model, you have to do a bunch of steps that I will show you in a second, and all these are quite difficult to do in one place. Plus, you need to provision some servers to perform these computations to create these models, and that can be cumbersome as well. So this is where SageMaker comes in. So SageMaker will try to help you all along the way for the process. So I will show you what machine learning actually is. And this is a simplified version. If you're a machine learning expert, don't get mad at me, please. But let's say you wanted to build a model, or let's say I wanted to build a model to predict what score you're going to get at your Certified Cloud Practitioner exam. So how will I do it? Say, for example, that I am a developer or a data scientist. So I'm going to gather all your data from the actual performance of my students. So I will ask maybe 10,000 students to give me information about how many years of experience in IT they had, how many years of experience with AWS they had, how much time they spent on the course, how many practice exams they did, etc., etc. So I'll try to gather as much data as possible, and then I'm going to label that data. So that means you need to say which column corresponds to what, and also you need to give some kind of score. And the score is the actual score for me at the exam that someone obtains. For example, someone did not pass 670, maybe he didn't do the course completely. That would be the reason. Maybe someone passed with high grade, so 990, or maybe someone with even higher grade, 934. So each student will get a specific score, and my guess is that based on the data that I've collected, I can predict what the score will be. So I've first done the labeling, and that labeling process can be quite complicated to do in practice. Then I need to build a machine learning model, which is how can I predict these scores from the historical data. So then you build that machine learning model, and then you have to train it and tune it. So this is another part that's actually quite difficult to do, which is how do I refine my model over time to better fit my data and my outputs. Okay, so now SageMaker and all of this will help you with the labeling, the building, the training, and tuning, but not only. Now we have a machine learning model, and it is created, it's fully working. So now I need to use it. So this is called deploying a machine learning model. So we're going to get new data coming in. For example, you are the new student, and I'm going to survey you, and I'm going to say, okay, how many years of experience do you have in IT with AWS? How much time have you spent on this course? And then I will apply, based on this data you just given me, I will apply the machine learning model that I have created from before. And then the machine learning will say, for example, hey, it seems like based on the data you have, I'm going to predict that the student will pass with a score of 906. And this whole process of labeling, building the model, training it, tuning it, applying it, can be all done within SageMaker. So that's it for a quick introduction, but I hope you liked it, and I will see you in the next lecture. Now let's talk about Amazon Forecast. And this is a very easy one because it allows you to do forecasts. So this is a fully managed services that will use machine learning to deliver highly accurate forecasts. For example, you want to predict the future sales of a raincoat. The idea is that it's going to be 50% more accurate than looking at the data itself, and you reduce forecasting time from months to hours by using a managed service. So the use cases can be multiple whenever you need a forecast, for example, product demand planning, financial planning, resource planning, and so on. So how does it work? Well, you take your historical time series data, for example, and you also add your product features, prices, discounts, website traffic, store locations, basically any kind of data you can to enhance your model. Then you upload this into Amazon S3. You then start the Amazon Forecast service, which will create a forecasting model, and you can use that forecasting model, for example, to say that your future sales of raincoats are going to be $500,000 next year. And that's it. Super simple. Whenever you see forecast at the exam, think Amazon Forecast. Another machine learning service on AWS is called Amazon Kendra. So this one is a fully managed document search service that is powered by machine learning, and it allows you to extract answers from within a document. That document could be text, PDF, HTML, PowerPoint, Microsoft Word, fax, etc., etc. So you have a lot of data sources where these documents may be, and you see some of them right now in the screen, and they're going to be indexed by Amazon Kendra, which is going to build internally a knowledge index powered by machine learning. And how does it help from an end user perspective? Well, we get natural language search capabilities, just like you go on Google. So for example, if a user says, hey, where is the IT support desk into Amazon Kendra, Kendra can reply, first floor. And this could be due to the fact that Kendra knows from all the data sources that it took that the IT support desk was on the first floor, which is quite awesome. And also, you can just do a normal search, and it will learn from the user interaction and feedback to promote preferred search results. It's called incremental learning. Finally, you can fine-tune the search results, for example, based on the importance of data, the freshness, or whatever custom filters you have. Okay. So from an exam perspective, whenever you see a document or service, think Amazon Kendra. That's it. I will see you in the next lecture. Next, we have Amazon Personalize, which is a fully machine learning service to build apps with real-time personalized recommendations. So what could be a recommendation? For example, a personalized product recommendation or re-ranking, or customized direct marketing. For example, a user has bought a lot of gardening tools and you want to provide recommendations on the next one to buy based on a personalization service. So this is the same technology used by Amazon.com. So when you go and shop on Amazon.com, and after buying a few products, what you will see is that Amazon.com start recommending products in the same category or in completely different categories based on how you've been searching and how you've been buying and user interest and that kind of things. So personalized is how you access this from within AWS. So you read your input data from Amazon S3. For example, it could be user interactions, these kind of things. Also, you can use the Amazon Personalized API to have real-time data integration into the Amazon Personalized service. And then this will expose a customized personalized API for your websites and applications, your mobile applications. Also, you can send SMS or emails for personalization as well. So you have all these integrations. It takes days, not months, to build this model. So you don't need to build, train, and deploy ML solutions. You can just use this bundled as is. And so the use cases is going to be retail stores, media, and entertainment. So from an exam perspective, anytime you see a machine learning service to build recommendations and personalized recommendations, think Amazon Personalize. That's it. I will see you in the next lecture. So now let's talk about Amazon Textract. And Amazon Textract is used to extract text, so hence the name. So you extract text, handwriting, or data from any scanned document, and behind the scenes, of course, it uses AI or machine learning. So we have, for example, a driver license, and then we upload it into Amazon Textract, and then automatically it will be analyzed, and the results will be given to you as a data file. And so you'll be able to, for example, extract the date of birth, document ID, and so on. So you can extract any data, even from forms and tables, and you can read PDFs, images, and so on. So the use cases for extracting text are multiple, but you could be for financial services to process invoices or financial reports. It could be for healthcare, for medical records and insurance claims, or for the public sector, for example, for tax forms, ID documents, and passports. Okay? So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. Now let's talk about the machine learning services on AWS, and you have to remember them all going into the exam. So recognition is a way for you to do face detections, to do labeling, and celebrity recognition. Transcribe is for you to get a way to get subtitles, for example, to convert your audio into text. Whereas Poly is the opposite. It allows you to use your text and create audio out of it. Translate is for you to get translations. Lex is to build conversational bots, so chatbots. And if you bundle it with Connect, then you can create a cloud contact center. Comprehend is a way for you to do natural language processing. SageMaker is a fully featured machine learning service that is accessible to developer and data scientists. Forecast allows you to build highly accurate forecasts. Kendra is going to be an ML-powered document search engine. Personalized is used for real-time personalized recommendations for your customers. And Textract is used to detect text and data and extract them from various documents. So hopefully you can remember this whole list. This will get you a few points at the exam. I hope you like this lecture, and I will see See you in the
actually to appreciate the deliver what your stakeholder wants as quickly as possible. And so they are focused on very short-term objectives and to the teams what they do. You have to have a mechanism by which you can still have that collaboration.
Architecture. As a matter of fact, with the layered architecture, domain to architecture isomorphism says this.
Welcome everyone to the
software architecture, that why is actually more important in architecture than how. Because I can look at a diagram and I can see how things work, but the number of hundreds and hundreds of hours that I have spent trying to dig out why you made a certain choice was actually more important.
You don't care what happens to it. Right? You got it. To compile that sucker. Okay. And the test should turn red. Good. And now we want it to turn green. And to do that, we're going to say what? Context dot gateway. But that's a complicated use case. It's got lots of exceptions in it. It would know about passwords. It would know about different open IDs or different places to get IDs from. And we don't want to do any of that. So this use case must call something like a gateway, but not a gateway. It must call some other kind of utility which knows how to set a validated user as being logged in. So it bypasses all the validation and just jams them into the system as being logged in. So all the validation is done up here. All of the goop that we don't want to deal with at the moment is up there, but this is the guy who knows how to establish a validated user is already logged in. Okay. What do you call that thing? What do you call it?
10 minutes later.
Gatekeeper. Oh yeah. Okay, let's try that. That's an interesting one. Gatekeeper. And no, this is not an episode of Ghostbusters. I don't know. Sometimes I just think this whole naming thing is a pain.
No. Names are important.
Yeah.
Well, first of all, like in picking the names of things, you get to be creative. I think,
Dean.
Well,
Bouncer. Yeah, that was creative. Yeah.
No, it was fun. It was almost like writing poetry.
Poetry. The poetry of names.
But if you pick a good name, it can really help communicate the intent of the design and help direct people in the decisions they're going to make after that fact.
Yeah, I know. Still frustrating.
It's time well spent.
Okay. The gatekeeper, and that's the interface, just like this one was. This is our gateway. The gatekeeper is going to have methods on it like set logged in user. And that's the only one we really want right now.
Right.
And then you will go to the gatekeeper to determine who's logged in. So the gatekeeper has to be part of the context.
It does, but it has to be different because we're going to be... Maybe we're going to resolve this later, but the gatekeeper is going to be different per session, right? So if you're using the web app and I'm using it at the same time, we need to be using different gatekeepers.
That's true.
Or at least it needs to be able to recognize us differently.
So gatekeeper is a per session.
Yeah.
Yeah, okay. We'd have to pull it out of some kind of a session object. And where do we keep the session object? For example, how would you pronounce this? See that green squiggle up there? Even my IDE knows that there's something wrong with this name. So if you had to, how would you pronounce it? Get why? Couldn't that have been get year? Or how about this one that I found in a well-known open source tool? MQDocs? PPP? No doubt those names were convenient for the authors, but what about the readers? I really don't want to find myself in a pair programming session saying, let's go get the MQDocs and PPP it over here. I found these names in another open source tool. How would you pronounce these names? Qt tests? Qt pass M? Qt pass S? What do M and S stand for? Couldn't these have been total tests, past scenarios, past methods, skipped tests, failed tests? Wouldn't that have been nicer? Remember, names are not just for our convenience. They are the tools we use to communicate. Others need to communicate too, so make your names pronounceable so that others can use them to communicate with each other. Long ago, in a faraway land, there lived a man named Charles. Charles was a C programmer. Like all C programmers, Charles needed to keep track of his data types. So, he invented an encoding scheme.